Hey Audrey, so these are from the first lesson that you needed help with. I think 73, 74 maybe. So let's look at how this works. We're going to find the surface area of a right circular cylinder that has a height of 30 feet and whose base has a radius of 10 feet. So we're going to picture that, right? That is a circle on top with a rectangle in the middle and a circle on the bottom. Remember the soup can that we talked about? This is like the label that wraps around the soup can. That is the lateral surface area, the side surface area. And then you have a top and a bottom. So remember, it's got the radius of 10 feet on both of these. So these are going to be identical circles. So we can say 2 times the area of the circle plus the lateral surface area, and that's going to give us our total surface area. Now, how do we get lateral surface area? Lateral surface area is going to be equal to the circumference of the circle and the height of the cylinder. So it's a rectangle, so it's going to be the circumference times the height. So that's what we're going to do to get that. First, let's find the area of the base. So we know to find the area of a circle, it's going to be pi r squared. So that is 10 foot times 10 foot. So that's going to be 100 times pi feet squared. The unit of measure always comes last, right? So there's our area of the base, but we have 2 of those. So that's going to be 2 times 100 pi feet squared plus the circumference. So what is our circumference? Our circumference is diameter pi, right? So our diameter is going to be 2 times a radius. So 2 times 10 is 20. So our circumference is going to be diameter pi. So it's going to be 20 times pi feet times the height, which we're told is 30 feet. That is our entire equation. So 2 times 100, that's 200 times pi feet square plus 20 times 30, that's going to be 600 times pi, because you have the pi here, feet square. They're both pi, so we can add them together. These are like terms. So that's going to be 800 pi feet square. That's our surface area. Okay? So logic your way through the problem. Draw your net so you can see what's going on. That's really going to help. And this is always the net for a cylinder. Circle on the top, rectangle in the middle, circle on the bottom for the base. And these 2 circles are identical for a cylinder. So you can do those parts together. And if you really think about it, what you're doing is you're doing circle plus rectangle plus circle. So if you need to think of it that way and do the 100 plus the 600 plus the 100, it's the same thing, right? It's how you need to think about it in order to wrap your head around it and solve it. So that is the answer for that problem. Let's look at the next one. All right, so here we're looking for volume. We're not looking for surface area. So we're going to find for volume, it's always equal to, for a right prism, the area of the base times the height. So first you have to find the area of the base. So we have a right circular cylinder whose height is 5 inches. So that would go here, 5 inches. And whose radius is 2 inches. So the area of the base is pi r squared, so 2 inches times 2 inches. So that's going to equal 2 times 2, that's 4 times pi, because pi is a number. So that comes after the coefficient, inches squared because we have inches twice. So that goes here. That's the area of the base. So 4 pi inches squared times 5. 4 times 5, that's 20. And then that's pi is a factor in there. And now we have used inches a third time. That's your volume. 20 pi inches square. That's all there is for that. Let's look at the next one. All right, so now we're doing surface area again of a right circular cylinder. Remember the net for a cylinder. We have a circle on the top, and then we have that label that wraps around the tube or the cylinder, and then we have a circle on the bottom. The height is 5 inches, so that goes right here. 5 inches is the height, and the radius is 2 inches. So we're going to do this 2 inches here. So now we need to find the total surface area. We're going to find 2 times the area of the base plus the lateral surface area, right? The sides. So ultimately, what we're looking at is 2 times the circle plus the rectangle. So what is this dimension here? It is the circumference of the circle, because when you lay this circle down flat, this edge wraps from one point all the way around to the beginning of the circle. So it's the circumference of the circle. So we've got 2 times the area of the base plus the circumference times the height. So first of all, what's the area of the base? It's pi r squared, so pi times 2 inches times 2 inches plus the circumference is going to be diameter pi, 2 pi r, and 2 times r is diameter, so diameter pi. So 2 times 2 is 4, so 4 pi inches times the height, I guess I just do parentheses, of 5 inches. So there's our values. So 2 times 2 is 4. 2 times 2 times 2 is 8. So 8 pi inches square plus 4 times 5, that's 20 pi inches square. So 28 pi inches square is your solution. Okay. All right, let's look at, I think that was the last one for this lesson. Let's look at the next lesson. All right, this is from lesson 75. So Jonathan uses 7 sticks of vine charcoal for every 3 drawing he creates. So he's got 7 sticks for 3 drawings. How many drawings can he create with 23 sticks? So all we need to do is put sticks in, put this rate with the 23 sticks. All right, I got 23 sticks. Put that over 1 in fraction form just because it's easier. And now we're going to take this rate and we're going to flip it so that sticks is on the bottom. So that means we've got 3 drawings. It's just like unit conversion. And 7 sticks. Okay, sticks cancels. So we have 23 times 3. Right, 23 times 3. That's 69 over 7. And our unit is drawings. Can we divide 69 by 7? No, we can't. When I say we can't, I mean it's not a whole number is our answer. So because we can't, we leave it like a fraction. This is the answer I'm looking for. Okay, 69 over 7. All right, so here's the next one. The softball complex requires 16 teams. So 16 teams for every 2 tournaments. All right, that's your ratio. That's your rate. How many teams are needed if they want 6 tournaments? So 6 tournaments is the number that we're looking for. All right. Or this is the quantity we're given, and we need to find out how many teams. So teams is going to be our answer. So what we start with is the information, the variable information that we're trying to match to. So 6 tournaments. Put that in fraction form so it's easy to see what we're multiplying. Now we're going to take this ratio and we're going to flip it so that tournaments, well, we don't have to flip it. Tournaments is already in the bottom. So 16 teams, 2 tournaments. Tournaments cancels. So we end up with 6 times 16 divided by 2, right? 6 times 16 divided by 2, and that's going to be the number of teams that we have. So we're just going to do that calculation. 6 times 16 divided by 2, so 48 teams. So I'm looking for 48. That's the response I want. All right, let's look at another one. All right, here's the last one. 5 Criterion team bikes. Criterion is just the name of the bike. So 5 bikes cost a lot of money. So we have $11,300 for 5 bikes. That's a lot of moolah. How much would the club have to pay for a dozen? A dozen is 12 bikes. So we want how much for 12 bikes? So this is the number that we're starting with, 12 bikes over 1. Right? Just set our fraction up. And we're going to flip this. Actually, we don't have to flip it. Bikes is already on the bottom. So 11,300. 5 bikes. Bikes cancels. As a unit of measure, that's what we're doing it. We're treating it like a unit of measure. So we have 12 times 11,300 divided by 5. And that's going to give us the dollar amount. This is our unit of measure is dollars. So when we do that on the calculator, because it's a really big number, and we divide that by 5, $27,120. That is how much 12 bikes would cost, which is a lot of moolah for bikes, in my opinion. So you see kind of how that works. This is giving you the ratio in the first sentence, and you just make a fraction of, this is going to be a fraction that equals 1. This is the equivalent of this. Whatever's in the numerator is the same thing, just in a different format in the denominator, right? So that's the same thing as saying there are 12 apples in 1 basket, right? One basket has 12 apples. So if you have 12 apples, you have 1 basket. They're the same value. Does that make sense? Then it's just written in a different format. They equal. You could also write it as an equal statement where you would say 12 apples equals 1 basket. If they're equal, then when you put equal values on top of each other in a fraction, you get the value of 1. So we're not changing the value at all. We're just applying a rate for that value to figure out, how one compares to another. It's exactly like unit conversion, the way we do like feet to inches or miles to millimeters. Not sure if y'all have done that yet, but miles to feet or miles to inches or inches to miles or inches to yards or any of that. it's the exact same process as what you use for unit conversion. We're just using different things besides lengths or distance. We're using other things that equal one another. So it's important that you write out what the number is so that you can flip it the way that it needs to flip in that second fraction when you apply your unit of reference. Okay? All right, if you still have any questions, feel free to bring that up tomorrow. I would be glad to expound on that in class. And I will see you then. Bye for now.